bugger has he got now? I hear you saying if you've not read the title to this video, which I assume you most likely have. But yes, here we are on the landing again. Excuse me. The reason being, when I get this cough cleared, the reason being is that this thing is huge comparatively, and to work on it, we ain't gonna get it in the lab to work on it. It is too big. So what is it? Well, it is a projection carousel. You might not know one of them. You might not know what one of them is, but I'm going to explain that to you in uno momento. What a projection carousel is well, it's a slide projection carousel. Let me just get in your way here. We'll do is just take the top off here. In this rotating section at the top are what are called slides. This is before projectors and stuff, and each one has a picture, and the light shines through it and it projects it onto a wall, so you can see the picture. Exciting stuff, or maybe not, depending on your viewpoint. Just going to put that back nicely, because they were sorted. Oh well. Okay. Anyway, so most of these machines will happily... That doesn't actually belong on it, by the way. I picked that up somewhere else, so yes, thought I'd put that on there to scare you. Anyway. Okay, so it's a big bugger, but this isn't a normal projection carousel. This is a computerized one, because what you do with these ones, I'll just go on the side here so you can actually see it without me getting in the way. Just flip my screen around so I can see what I'm doing. Right, okay, on the side here, somewhere here, if I can remember how to do this, you have a cassette. This is called an endless cassette. Yes, just confirm that is an endless cassette. This will play in an indefinite loop. But each recording can last 6 minutes maximum. This goes in the side, like that. Amazing. And you record a commentary on this. I've got the microphone, but it's downstairs. Silly bugger, I forgot to get it. So what you do, you record your commentary on this, and every time you want it to swap pictures, you press a button when you're recording, and it puts a tone on the tape, which you can't hear, but the system can. And that will tell it to automatically change the slide. And you can tell it which slide number to move to. So that was pretty advanced stuff. And these things would have cost a pretty penny, especially as it's a Bell Howell. This one was very kindly donated to me by a building that's associated with where I work. They knew what I do and they said, would you like it? And I said, oh, go on then. Possibly. Yes. I snapped their hand off basically. Now it comes with the case for the thing, which is just a normal case, so that's nothing special. A remote control, which is still working. Massive remote control. Nice. Very early. These are only available on this top line product. And the instruction manual, which is extremely handy. I'll have to hold it at an awkward angle here, but yes, it's in 4 languages and shows you around it. Now, as is typical, it does have issues, but I'll show you them in a moment. We'll have a quick look around it first. First of all, this thing can project from 2 ways. You can either open a vent on the back here and it projects against the wall. I'll show you that in a moment. Or it can project onto the screen here. When that door is closed, it automatically projects onto the screen. Here, excuse me, this cough's terrible. Excuse me. Right, here is the cassette controls and the volume, power switch, controller for the lamp, which is just a normal halogen lamp. Here's the computer itself, or the controller for the computer, and here's the sound. On the top, an access door for the lamp, few controls for focus and stuff, and this funky little thing, which I'll now zoom into for you. Yum yum, so nice like that. Come on, there we go. Oops, not the button. This funky little thing is the receiver for the remote. Excellent. And on top you've also got the carousel itself, which contains all the files. This is awkward stuff. That's something you gotta do when you got something so big to deal with. Okay, so that's the front. This is the carousel itself, which contains the pictures. It just lifts up like that. I've now got to find where the slide went, because my wife, well, the Fluffy, very kindly arranged all these. Now I'm messing up her display. She will not be pleased. Looks like it goes there. Okay. Let's put the carousel safely out of the way. Right, on the side we have the cassette mechanism here, which, there we go, that comes in and out there. We have a pulse on and off. This is the pulse which controls the carousel position, so you can select it on or off. PA on or off, that's for the microphone input, external speaker, and headphones. Nothing else on this side. Does have a nice carry handle. The back, not that side, nothing. The back, this is the door I was on about. If you open this, the bulb can shine straight out and project onto a wall. This is a little storage space for power cable. That time of year, bloody coughs. Plus, I was biking recently, which didn't help. Excuse me. And then here is a door where you can store carousel inside it. Very handy little storage area. Not much else to show you. Right, okay. Now, I don't know if I can get this working, but as usual, we're going to give it a shot. So what I'm going to do first of all, just put the carousel on. Just line it up. There it goes. And I'm going to switch the power on and I'll show you what it does and doesn't do. Okay, power is on. Now you probably can't see from there, but the bulb is running, power fans are running. We've got no lights on these LEDs here. The computer itself is showing a display, although if you use it, there's no response. Now, I have done a quick check to make sure it's not the keyboard cable itself. I've reconnected that, still no response. I'm starting to think that it's a power issue. This is due to several reasons. It doesn't respond from the remote either or there. No. If I press play, we get a lot of flashing here on the LED. I don't know if you can see that on the camera, but that is flashing a lot. So that leads me to think there's a power issue here. Maybe something to do with the power supply. We have done readings on the computer itself and it's getting 4.97, so I don't think that's too bad. But as you can hear, when that tape's running, listen carefully. Let's stop. How do I stop this? Stop. The fan's slow as well, so I think there may be an issue with the power supply at the back here. So, what I'm going to have to do is go in and operate. Oh joy. So, I don't know how to get into the back. There's a lot of screws. That doesn't necessarily mean it'll let me, ow, it'll let me, that was loud, ow my ears, it'll let me in. So, I'm going to switch off the camera and see if I can find my way into this bugger. I'll be right back as soon as I've found anything. Remember, if you're doing an operation like this, remember to take photographs of everything as you go through it. Therefore, you can find out how it went back together and put the screws safe too. I'll be right. Before I take this apart anymore, I thought you'd find people might have a look at what we found so far. So this is a cassette mechanism, the cassette control board here. I haven't examined any of these yet properly. This looks like oh, it's just gone out of the bloody head. Oh, yeah, one of them anyway. Coils and stuff inside to get the power right. Going into this board here, which looks like it controls the motor, the light, and gubbins like that. I was just looking around, and here's the lens, which looks at the slide itself. I haven't looked at how the slides get down or anything yet, but there's the mechanism itself. I'll have a play with that, examine that, make sure it looks okay to the best of my ability. And yes, here we go. Light comes through here. This is the shutter. Comes down, lets the light through. That focuses down here, and then you can either go out the front or out the back. Quite simple actually, isn't it, when you think about it? Right, oh, fuses, loads of them. Right, multimeter. Okay. Right, ladies and the gentlemen, I think we found the cause. This is a transformer. Hey, I've remembered what it is. And as you can see, this takes this AC coming through this. Sorry, yeah, we'll come through this. Alright, this is the transformer, which is stepping up and down the power voltages. Comes through here, goes to this board, and you've got 3 different rails. These 10 volt, 3 volt, and I think there's a 5 volt rail on this. Then goes to this board, and to run the computer, not the analog stuff, the computer and stuff, you need to bridge rectify this to a DC signal. That's a nice flat electrical signal. And this board appears, that's my phone, this board appears to do that. As you can see, there are, I'm not an expert, but what I can see, I think, 2 bridge rectification circuits, which are these ones, which convert from AC to DC. And there's one there, and there's one there. There may be more on the back. I've not looked because it's an awkward fitting and I'm not going to bother to look. Yes, and when we looked, well, when we put the multimeter on, there's 4 fuses here. Don't know why there's 4, don't ask me. But 2 of them are blown. There we go, the other one's in the same condition. So, don't think I've got any of them around. So I'm going to have to order them off the interwebs, put them in and see what happens. But I think that may be our cause. Other than that, I've had a quick visual inspection, and visually, doesn't mean it does work, but visually everything seems in order. There's no damage. Ultimately, it's not that complex a machine. There's not too much to the electronics, so I've also tested the output from this transformer, and that's within limits, so yes, I think that's our problem. I don't think, as in, I think when we get those fuses replaced, that we shouldn't get any more problems. But I'll get these ordered, and we shall find out, shall we? Yeah. Right, we are back, and it's a few days later, and I'm just getting my key from down here, back on the landing, because of the lack of space for this project. Now, if you look carefully up here, you will notice that there's a bit missing. It's here. It's the power board. This is the main power distribution board where we found the fuses. Look at this light here. We found the fuses that were broken, and I took it out eventually because it's really awkward to get out. And on close inspection, these are the fuses that blew. We've got new ones in there. Close inspection, there was 2 of these capacitors here. This light's not very good for this sort of stuff, but I'll do it as best I can. Right, there were 2 capacitors here. This one and its twin here, was here. This one had some damage, so I've replaced it. But I couldn't get another axial, so I've just replaced it with a radial, which does the job just sits a bit differently. So hopefully that will do the job and there's no more problems. Now the plan now, I'm going to install this loosely back into the machine. There are a lot of cables to go back, but luckily I used my phone to take some pictures, so I should be able to hopefully quickly work out where they go. But what I'll do first of all is plug this board into the transformer, test as nothing blows, then I'll slowly plug each part of the system in, so that if there is a problem in one of the systems that's causing a short and blowing the fuse, we can find out. So I'll test it after each power up. We also found in the mains lead there was a 5 amp fuse instead of a 3, so I have replaced that. So what I'm going to do now is start reinstalling the board and testing each section. So I'll be back once we've found what happens. I'll be right back. Right, Houston, we have a problem. Right, it switches back on. Lamp runs. Can't get a response out of the system here, computer. And this third fuse down blows every time. Fourth fuse, which had blown before, is now working fine, but the third fuse is not happy. So, what I'm going to have to do is find out where that goes to. Even when I just plugged it into the system here, I plugged in, which one was it now? That comes from the transformer, plugged that in. This comes from the power switch, so I plugged that one in. Yeah, switched it on and bang, it went. So, I've got the tape playing here. Let's just stop that. Stop! No sound. Let's stop. There it is. So, Houston, we still have problems. So I'm going to have to take that board back out, trace where that goes, and see if we can find the problem. Lovely. Right, thank you very much. Right, it's a few minutes later, and we've been testing it with just the transformer plugged in, and that blows every time. Now, we've tested the transformer and the outputs from that seem to be fine. So, it's something on the board, but this goes through all this bridge rectification circuits here. And then up to this chip here, through resistors and all sorts. So, I need to find a way. I've either got to test each of these components somehow, find a way, I'll look on YouTube, or replace them. So, that's, need advice. How can I test these, if possible, and the resistors and anything else that this heads towards? I'll see if I can get a route in a second. I'll be right back. Right. A short while later, and I've been busy. Now, I found out how to test resistors and diodes from the internet. Tested all these resistors here. These come up with their usual values. Now, this one and its buddy, just put the multimeter. This one and its buddy here are apparently 68 ohms resistors. Now, if I apply some multimeter stuff to them, I'm getting, can't see this on the screen. See that? Okay. So get this as best I can. It's an awkward situation here. Let's just put it over there. Right. Just about to see now. Put it over there. Over there. So I've been using the online calculator to tell me the values. Now there are some interesting things about these two resistors here. If I zoom in on them. Right, they are blue, grey, black, which makes them 68 ohms according to the online calculator. Now, if I whack the multimeter on them, just put it out so you can see the screen, hopefully. Yes. This one, we're getting a reading of 0.2. So I think that one, let's get that for you. 0.2. So I think that one is buggered. This one, which is mounted the opposite way, has a reading of 77 ohms. So that is not good. It should be 68, according to the online stuff. So, and the other thing I've noticed, it's interesting, if you put my multimeter into continuity mode, all the resistors, you don't get continuity through them. You get some figures, but you don't get continuity. This one most definitely do get continuity. So is that telling me, along with that, that's buggered, that needs replacing? This one, yeah, you get a little beep, but that's it. So I think those two need replacing. They're on this circuit for this. These diodes are on the circuit for this. I've been testing them. How did I test them now? Oh, I just did them in continuity mode and put the probes by, and there we go. There's no shorts. So it would just be a 1. And they're all in a similar range. That works for all the diodes across both boards. These little diodes here, tiny things, get an open signal on them, but I don't know, because they both do it. I'm assuming they're diodes. Let me put it in here. Right, just put it out a little bit. Come on. There you go. Right, this little bugger here, the diode marker there, it's got diode symbol underneath on the board, so they are both diodes. They don't know if they should get the open signal. Don't know if that's due to their type. So we've definitely got a problem with the resistors here. This one, I'm thinking that's normal because they all do it. So diodes seem to be fine. There's definitely a problem here. That's been replaced. I could do a resistance test on that. This here is a, what is it? Well, it's going to be some power thing anyway. W9 resistors A1. So I don't know what that is. I don't know how to test it. I also don't know how to test transistors. Right, this resistor is, let me show you an example of working on this. This resistor here, at the back, I'm going to have to pull out so you can see the screen on my mobile. There we go. Right. This resistor here is brown, black, brown. So I'll go to my little, see it somewhere, let's have a look. Go away, Chrome, okay. Here you are. So we go, it's brown, isn't it? Brown, black, brown, calculate, and that's 100 ohm resistor. So we've got that on 200 ohms, and let's have a look what we get. Come on. Yeah, 98, flashing them out there. Yeah, so that one's fine. Got to test these as well. I have no idea how to do that, so I'm going to find that out, and I'll be back in a moment. Right, just sorting you out here. There are 2 transistors. Now I don't know strictly how to test them. I've got a rough idea, and if I I don't know what the value should be, but if I put a do an ohms test on the base and collector wall, should be one of these two. There we go. Got a reading of 98.5 ohms, and that is identical. Can you see? Tell me if you can't see. That's identical on this one. Yeah, so they're either both broken or they're both working. So that's it so far. So I think our problem. You have to forgive me for these unorthodox views because I'm stuck here on the landing in the tight area. But, so, I think we've got to replace them. Diodes are fine, transistors probably fine. No idea how to test that, so if somebody could tell me, that would be handy. But, how do I test that if the fuse keeps blowing? Somebody please let me know. Diodes seem to be fine. Resistors here, they seem to be buggered. Think they're working. So, advice please. Do I need to just replace them and then try again? Let me know, and then we can go on to the next phase, order the parts and try this again. But because that fuse is blowing with just the power board plugged in, we know that the first problem is just on the power board. So let me know what you think, and then we can continue our work here. Our work is never done. Thank you very much. Right, it is the day after approximately 24 hours, and yes, the mystery deepens. These two resistors, which we thought were at fault, I took them out of circuit to test them independently, and they both test at 78 ohms, which according to the colour chart should be 68 ohms, but it comes up at 78 ohms when they take it out of circuit. And they go back to playing their usual tricks. Get a multimeter in here. You can see it's displayed there. That's good enough. And they go back to playing their usual tricks when they put in circuit. 78 on that, and 0.4 on that. So I don't know what's happening there. Excuse me. Now the diodes, excuse me, if I put this on continuity test and test the diodes, we shouldn't be able to send electricity down the wrong way, which on these, all four, is fine. If I swap to the right way, still see a clock, good, display, yep, power goes down the line and we get a nice reading. Same happens with these. If I send electricity this way on these tiny ones down here, I don't know if you can see. CR1, this guy. If I send power down normally, I get 0.639 on this diode. Now I don't know what its value is supposed to be. I don't know how to read them. Excuse me. But if I reverse the polarity, I wasn't doing that earlier. Yes, I was getting a short earlier. It seemed to be a short. Just push these resistors in, just see. Typical. Right, but this one, if I put this on the wrong way, there you go, I'm getting a short. Put it on the right way. Come on, get in there. Okay, 0.01. And continue. That's probably due to lack of resistance. I don't know how these diode things work properly, fully. So I need this explaining to me, if anybody would be so kind. Also getting it on there, if I reverse polarity and send it the wrong way up it, I'm getting a continuity reading, which I'm sure I shouldn't be getting on these, because they are, as far as I'm aware, diodes, just very small diodes. Or am I wrong? And could be wrong. So they're working fine out of circuit. That one works fine in circuit. This one works fine out of circuit, but when you put it, excuse me, a lot of coughing going on here. When you put it in circuit, yes, you're getting this short and very little resistance. Well, it's not a short, it's due to lack of resistance. I wonder what's causing that, because this capacitor is in circuit with that. I think these are as well. But they seem to charge up fine when I do a basic continuity check. So, also for information, this is the fuse that's blowing, and that capacitor is in that circuit. So, anybody got any ideas what's going on? What I can do, if anybody wants, is create a double picture, and I'll layer the front onto the traces on the back, so you can see where everything connects, if you wish. But if anybody's got any ideas, oh, you didn't see that last bit, but yes, a little capacitor up there. Probably didn't see it actually. So if anybody's got any ideas what's going on here and causing that fuse to blow, and that to read completely wrong, yes, that seems to charge. Please let me know, because I'm running short on ideas. Other than that, thank you.
You need to quit being dirty. You're a dirty boy.